Okay. So to recap what we talked about on Tuesday, we talked about lists. Remember, lists are square brackets on each side. You have items that are inside of the list, right? And those items can be of any other data type. So they could be strings, integers, floats. They could be more lists. So lists inside of lists. You could have any other data type inside of it. All right. They are all comma delimited, meaning that they have whatever their value is with comma separated as they go through. And we read indexes from left to right. If you guys remember, indexes start with 0 on the left and work their way to the right. If we're going from right to left, what's the last one in the list? -1. Great. So if you're going from right to left, you can use negative indexes in order to go from -1 across. All right. You can use slices. That's where you put the colon in between, and that will give you everything in the values. Remember that the second value, for example, 1:4, means that it's going to go up to the fourth index, but not included. Okay. To get the length of a list, you can use len, the len function. To change values, you simply use the assignment operator by taking, let me blow this up a little bit here. By taking the name of the list, in this case, it's spam, right? We say which index we want to manipulate. In this case, it's number 2, which means we're modifying what? If this is the list. Rat, right? So we're going to change rat, and we're going to say that's equal to spam1, which is going to be what? Aardvark, right? So then we're going to end up with a result of cat, aardvark, elephant. Okay. You can do list concatenation and list replication just like you could with strings. So you can add essentially or concatenate two lists together. You can also replicate those lists by however many times you tell it to. Okay. We talked about how to delete things from the list if you know the index. So if you know the index, you use the delete or the del keyword, the name of the list, and you put in here which index you want to delete. Okay. All right. So that brings us into working with lists. There's other things that we're going to want to do. We did all of that. We talked about using a for loop. You can use a check. So in your if statements, you can do a check to see if something is in the list. So if we wanted to check to see if Howdy was in this list that was passed through, we could get that. That gives us a true or false, and we can use that in an if, elif type statement, right? So if we're adding names to a list, we could check first to see if that name is in the list before we try to add it. Make sense? What else we got here? You have what's called the multiple assignment trick, which what this does is you have a list here. So you have a list of cat, right? That cat has variables or values in here listed as fat, gray, and loud. Right? Those correlate to something like size, color, and disposition, right? So if we wanted to say size was equal to cat 0, meaning that it's going to be fat, the color is set to cat 1, so it's gray, and disposition is set to cat 2, which is loud. All right. Instead of having to say 4 different lines here, we can have 2 lines. 1, we define what the list is, and 2, we say size, color, disposition equals cat, which then automatically assigns these out based on the order that you put those in here. Everybody understand how that works? It's important because this is a quiz question and a midterm question. All right. So no, this is called the multiple assignment trick. The idea is you can manually set these out, right? If you want to do this all in one line of code, you can do this. However, you have to pay attention because the order you put these in is the order that it grabs it out of the list. That makes sense? So if I said disposition, color, size, well, then all these are going to be in the wrong spot. Okay. If in the multiple assignment trick, I tell it one more variable name that, and this only has 3 possible values, you're going to get an error like this that says not enough on values to unpack. All right. We talked a little bit about the enumerate function, enumerate basically allows you to return both the index and the value of whatever's inside. Okay, so instead of you having to go look up and find out what index it is, you can do this with the enumerate function, which gives you back a tuple. All right, so tuples use parentheses around them. All right, they're just like lists, only you cannot change them. All right, so we have a new data type. We have lists, which uses square brackets, and we have tuples, which use parentheses. So let me show you what that looks like. So we could have something like cats, and we could have equals Sam. Let's do a square bracket. Sam, Fred, Whiskers. Okay. My finger stopped right here today. Okay. We have cats now, which is a list, right? We could also have cats as a tuple, which looks like this: Sam, Fred, and Whiskers. All right, notice the only difference is these have square brackets and these have parentheses. All right, tuples act and operate just like a list. The only difference is we cannot change a tuple. Okay, once we create it, we can't change it. So we typically would use a tuple for information in our programs that we would not like to change. So if we wanted a default setting of the amount of delay that we have for print statements, or a configuration of an API key or something like that, that kind of stuff, we would put in a tuple and not in a list because it's never going to change. All right, that makes these mutable, which means we can change things. That's the terminology. Immutable means that we cannot change it. All right. Everybody know the difference between lists and tuples? Again, they operate the same way. The difference is a tuple we don't change. And because it never changes, it's technically faster than a list. I think that's another quiz question somewhere. All right. Okay. Let's see here. We talked about random choice. This allowed us to pick a random one out of a list. So we import random and use random.choice and then pass in the name of the list, and it will randomly give us one of the options. We can use random shuffle, which will randomly shuffle this list. Okay. Let's see. Augmented operators. This is a little outside of a list, but you guys remember in the past when we said spam equals 42, then we would say something like adding 1 to it. We would say spam equals spam plus 1, right? That would make spam 43 now. We can shortcut that by just saying spam plus equals 1. It's important that you use plus equals 1 and not equals plus. It's very easy to get that flip-flopped. So if you want to increment a value that's an integer by 1, you could just simply say spam plus equals 1, it would add 1. If we said spam plus equals 10, it would add 10 to it, right? This is just shorthand of writing this all the way out. Doesn't seem like much, but if you're writing big amounts of code, it would save some keystrokes. All right. Same way with minus. If you want to subtract 1, spam minus 1, or spam minus equals 1. Multiplication, same way. Okay. So for example, all of these are equivalent to one another. So if I want to plus equals, it would look something like this: minuses, multiplication, division, and modulus. Anybody got any questions on plus equals? You can also use this to do string or list concatenation, meaning I could have the spam as a variable hello. And if I want to add more to that string, I just say spam plus equals, and I add another part of that string to it. So if for some reason you're building this long string out and you need to add things to it, you could do that in this fashion. All right, anybody got any questions on those? All right, now we're going to get into methods, and there is a whole lot of methods for lists. So you have delete. If you guys remember that, that is a delete statement. We put in delete, we put the name of the list, and in square brackets, we put the index we want to remove. But we need to do other functions with a list, right? So for example, we know how to delete stuff. We don't know how to add stuff yet, right? So say we have this list up here, right? And I want to get back the index of Fred. And I can't see this, right? Because I'm an end user. I have no idea what the index of Fred is. So to get that, I would use what's called cats.index. In this .index method, I pass it whatever the name is that I want to get the index back for. This will give me some index number. So if I print this very simply and run this, I get back 1, right? And that's what I should get for Fred. Is that right? Fred is in the 1 index. Not the first index, but the 1 index. All right, so this .index allows us to go figure out what the index is of whatever variable. This is a whole lot easier because we don't know what index these things are in, right? Unless we printed out the list. Then the user would know. So we have .index. The next one we're going to look at is .append. .append will allow us to add something to the list. So if I want to add a new name to cats, I would say cats.append, and then I would put whatever I want to append to this list. And this is going to add it to the end of the list. So say I picked up a new cat and we're going to call him Tuxedo. I don't know why, but that's what we're calling him. We would use cats.append, and that would add Tuxedo to the list. All right. Now, if we just printed out cats, and we run this again, you can see that our list now has Tuxedo at the end. So append always puts it at the end. Everybody got that one? Okay. All right. If we want to insert something at a particular spot, in other words, maybe we don't want Tuxedo to go to the end. Maybe we want to add him in between Sam and Fred. Okay. So to add him between Sam and Fred, we would use cats.insert. All right. Insert requires 2 different variables. One requires the index at which we want to insert it. So if we want to insert him between Sam and Fred, what index do I need to give it? 1, right? So 1, and then I put it whatever I want in there. So we're going to put Tuxedo in there. And now if I go ahead and print cats back out, not prints, print. There we go. It prints the cats. Okay, so we can see Tuxedo got put in between Sam and Fred. So append takes 1 variable, and it's just whatever you want to add, always adds it to the end. Insert requires that you give it the index and whatever variable that you want to insert in. Okay, so where that would be nice is maybe we need to figure out what the index of Fred is so that we could insert it in between here, right? So if we always know that we want Tuxedo to go before Fred, we could actually take this index, and instead of 1, we just put that in here. And so what this says is we always do the inside parentheses first, right? So this is going to run this piece of code first, go find the index of Fred, right? Wherever that index number comes back, we're going to insert Tuxedo in front of it. Then it runs this whole insert. So you could marry these 2 or bring this into one big line. Okay. If you guys lose this or not following, please let me know and we'll give a ton more examples because it's important to know how to operate within these lists. Okay. We talked about using delete, right? So if I wanted to delete Fred, I would have to say what? In this list up here. Ignore that we did this. So if I wanted to delete Fred out of my list, I would have to type what? Del. Cats. 1, right? And that would delete Fred from the list. So if we print cats, we can make sure that that works correctly. It's not hidden. There we go. There we go. So Fred's gone out of the list. Okay. We took one out. Now, if we didn't know what index Fred was, we could use remove. So we could say cats.remove, and we just want to remove Fred. Okay. Now we don't have to know the index. We just need to know the value that we want to remove out of our list. And so if I print cats now, we can see we get the same result. So we use delete when we know the index. We use remove when we know the value that we want to remove. Okay. We want to sort the list. So say we have this list of Sam, Fred, and Whiskers, and we decide we want to sort that alphabetically. All right. We would say cats.sort. Okay. And then we could print cats out. And it would sort it alphabetically for us. From that point on in the program, anything below this, cats is automatically going to be rearranged, which means those have new indexes, right? Fred is now what index? 0. Sam is now, and Whiskers is 2, right? Yeah, so sort by default will do it alphabetically. Okay. You also have options to do that in reverse if you wanted to, in which case we would say sort equals and then reverse equals true. And that would do it from Z to A. So if we run this, you can see now it's the other direction.
Reverse equals true.
Reverse equals true. Yep. Now, there's actually a shortcut for that one. You can use dot reverse, and it will go ahead and do that as well, as long as you only have strings in there. So instead of saying dot sort, you could just say dot reverse like that, and it would go ahead and do the same thing. We run it, we get the same result. That is a new Python 3.11 feature. Actually, it's 3.7.10, somewhere in there. All right. You have another feature is if you have a list like this, where you have uppercase characters and lowercase characters inside of there, we can use a key of str.lower, which means take your strings and use lower first, in which case it would sort it with lowercase a, then uppercase a, then lowercase z and uppercase c. Does everybody see how that works? So by default, it will just sort it AZ, lowercase first, uppercase. If you tell it string lower, then it's going to make sure that it's all A's with the lowercase ones first, then the uppercase, then all the Z's, and then the uppercase C's. Okay. If you have something in there that is not a string, so if I had integers in here, for example, and I tell it to reverse this, it will put the numbers first, and then it will do the alphabet afterwards, right? However, if I have, say, capital Sam, and maybe I put another one in here that's lowercase, so Sydney, right? And I run the reverse, you can see that it puts Sam, capital first, and then lowercase Sydney. This is on a reverse. If I do a sort, it cannot sort the list, right? Because we have integers and we have strings. So reverse can do it, but sort cannot. I know it's odd, but that's how it works. Okay. So if you have a mix of integers and strings, you cannot sort that. All right. Anybody have any questions on all that? Okay. Yeah, so say we wrote a quick little program here that would bring everybody in this class into a list, right? So we call something like students equals, and then we have an empty list. And then we would go ahead and have a program that would be get student. Right, and that would be something like print what is the student's name. Right, and then we say student equals input. And let's give that something a little fancy. And then we can make sure they give us a name, which right now we can't really check for that. But then at this point, we would do what to add that to students? I'm going to get rid of this. Yes, we would append. So let me just make this a simple program here. So we would say student dot or students dot append. And then what are we appending? Student, right? Okay. Let's do this for say 1, 2, 3, 4, 5, 6, 7. Let's do 5, right? So for I in range of 1 to 5, right? That should get us 5 numbers back. We will run this code here. At the end, we can print all of our students out. So we would say something like for student in students, print student, right? And then we could say print in alphabetical order. These are, and then we would sort it. So students dot sort. And then we could run this same code right here, which would print it back out in alphabetical order. And so ultimately that would look like when we put some empty prints in here, so it prints out okay. We run our code. All right, so we need a student. Caden. Sierra. I was gonna say I spelled that wrong. I didn't hit enter yet. What's that? Alex. I need another name. Jesse. All right, so I didn't get 5 because my range wasn't correct, right? I said 1 to 5. I actually needed what?
1 to 6.
1 to 6. All right. So we've got these 4 students. We can see that it prints them out because we did them in random order, and then it will go ahead and print them out in alphabetical order. So that's one case as to where you would use this, is if you wanted everybody like a roster or something like that, you could use it to sort that out. If you had a bunch of money currencies come in there and you wanted to sort from items that are higher or lower, something like that. Okay, great question. Now, right now, these lists that we've been building out, this is like an empty list, right? Let's say that we put those same students in our lists. And Alex. Okay, so we put those all in our list. If this gets super long, so let's keep going. Who else we got? We got Oren back there. I'm still trying to learn names. This is a test for me here. Gage. What's your name back there? Brian.
Hi.
With a Brian. Okay. What else we got?
Softly.
You're gonna have to help spell for me, right?
SOKLY.
Okay. All right. Who else we got? Luke, that's. If I don't talk to you enough, I don't know your names. These other guys I've talked to enough in clubs and stuff.
Did you know my name?
I did know your
You
name.
did.
Yep.
You know my name.
No.
Aiden.
What is it? Caden?
Yep.
Oh, well, great.
No.
We got-
Aiden.
Oh, Aiden.
I heard Aiden. Oh, it's with the E.
It is the E one.
Yes.
All right, we have an E one, an A one too, right?
Oh.
In the club. Okay, so I'm not going crazy here. All right, so notice as I type these, it kind of runs off the screen, right? And that makes it a little hard because when I click down on the next line, I can't see nothing. I got to drag this all the way back over. So what we can do with lists is we can click at the start of this next person and hit enter. And these, you'll notice this automatically puts them all left aligned over here in this list. Okay. This is really important when you get any more than 3 or 4 things, put them in a nice clean list. You can either use this sign at the bottom or you can leave it on the end, however you want. And you can also have a space up here where you can see where it's all aligned to. It really helps make it clean when you start having a lot of things in a list. Okay. Plus, it also keeps you from scrolling off to the right. Now, in Python, there's a thing called PEP8 compliance. If you guys were coding permanently in life, you would want to make sure that everything's squished over on the left, right? You can't run beyond 80 characters to the right, is what that means. In a real editor like PyCharm or something you would use in the advanced course, it would tell you you're running on too long and try to swing it over for you. So, okay. So that's the big thing with indentions is notice that these are all indented at the same level as you go through here. If you were to go here and press enter and it kicks you back over to the beginning, you probably have a typo somewhere. Go double check your typos. All right. What else we got here? So indexes. Okay. So here is one little short program in which we build a magic 8-ball. Okay, so we import random and we're going to have messages, and these are all our messages. And in this case, these are all off. So let's get these to where they're all aligned correctly. I'm using tab to get them back in there where they're supposed to be. Oops, but don't click it in the wrong spot or it causes the problem. Okay. So what this does is it looks at our messages list. And it says random.randint equals 0 to the length of messages minus 1. Everybody know what that means? Well, let's break this down. We need to find the most inner parenthesis one, which is this. So what is len messages doing? Right. So it's going to calculate what? How many is there? 9, right? So that puts a 9 here. So if we just copy this, we'll just break it down so you guys can see what it would look like. This becomes a 9. And then why would we subtract 1 from 9?
That's your taking.
Aha, the index of all these starts at 0. You're right, right? We want to take 1 away because our index starts at 0. The idea behind this print is that we're giving it a random index to print out. Okay, so if we do 9 minus 1, we're going to get 8, which means our range is now going to say, give us a random integer between 0 and 8. And that goes what? Up to 8 and includes or includes 8? 8 includes on a random integer one. So that's the reason that we subtract this out like we did here. Okay, if we added more to this list, I don't know, I'm just making something up here. Now we don't have to recode our application as if we hard coded it this way, because here it's going to calculate the total length, immediately subtract 1, and the code keeps working. We could add 100 different messages. We don't have to change our print command.
So you could do it this way, you would just have to go back.
You would have to go back in and edit this every time. Yep. So that's the beauty of writing this, what's called Pythonically, meaning that you're coding it in a way that your changes will not affect your code downstream. All right. So if we do this and we say a random number between 0 and 8 and we pick 5, that means that this now becomes 5, which means print messages 5 ends up being which one?
Ask again.
Concentrate and ask again, right? So if we run this,
Is it both?
no.
Oh, okay.
There you go. So the first one here is because it picked a random one, right? This one is the one that we hard coded to say, give us the 5th one. Is it the 5th one? Is this one the 5th one in the list? It's the 6th one, right?
So why does it?
So why did it give us this one?
Is it?
Because it's not the 5th one in the list, it's the 5 index, right? We start indexes at 0. So you got to be careful when you say that, right? I have to catch myself on that all the time. It's not the 5th one in the list, it's index number 5, and we always start at 0. All right. Trust me, it will catch up with you when you get out there and do your midterm stuff. All right. Everybody see how that kind of works? Use len messages to calculate the total length. Always subtract 1 so that you can deal with indexes. Then we just use random int to randomly pick one. Now, how could we do this in a much easier way than what we did here, given the tools that you guys have learned today and yesterday? There's a really cool method on random that lets us do this. Actually, it's a function off random. There you go. Random choice, right? So instead of building out all this stuff that has to calculate an integer, we can just say random choice, pass in messages. And actually, it looks more like this, random dot messages. No, sorry, random dot choice. We pass in our list, which is messages. And then we just run that. And every time we do that, it'll give us a new. Way easier when you're trying to pick out a random one through there. Because the other way works, right? We're just having to calculate the integer of whatever index it is. Choice will save us all that code.
So why didn't it put that in the book? Like, why did it put that part right?
It does both, right? So if we scroll up here. Oh, for the magic 8-ball?
Yeah.
It's wanting you to understand that it's calculating the integer and how you could go about doing that.
So there's like the len message, so if you put like. When it subtracts 1, and it's like, it goes from 9 to 8, does that make it so they can't do the same one?
No, all that does is make sure that when it calculates this random number, that it calculates one that is within the indexes of however many there is in that list. That's why that -1's there. You always got to subtract 1 because your list indexes start at 0. So if you have 9 of them, we know that our last index is 8. All right. Let's see, sequence data, PMP. Okay. So now we talk about mutable and immutable. All right. Those are what I was talking about earlier when I talked about tuples. Mutable means that we can manipulate it. It's the easiest way to remember it. All right. So we can add values, we can remove it, we can change it, we can do whatever. A list is a mutable data type. All right. Things like strings are immutable, meaning we can't change a string. Right? We can't append to it, we can't remove it, we can't do anything. We can reassign it, right? But I cannot change what's inside of a list. So when it comes to lists are mutable, tuples are immutable. Strings are immutable. We can't change a string. Once it's said, we have to reassign the whole string. So what does that look like? If I had a string here called name equals Jason, if I say name is now equal to Sam, I did not change Jason. Okay, I erased the whole name variable and created a new name variable called Sam. It looks like I changed it, right? But I didn't change it. I didn't manipulate it. I just wiped it out and reassigned it. Okay. If I wanted to add an I in here because I misspelled it, I don't know why it's a Jason. I can't manipulate that. I'd have to actually change it. I can't say something like name. Let's see, that would be 0, 1, 2. This would be in the third index. I want to add an I or manipulate that to an I, right? I can't do that. It's going to run and it's going to say that I can't do that on a string. Okay. All right. Let's see what else we got here. Append, list, changing data types. Okay, so that's where we talk about tuples. Again, I've already talked about this a little bit. They're exactly the same as lists, only we use parentheses around them, and they're intended that you cannot change them, right? They're immutable. You would still pull values out with square brackets, just like you would with a list, but we cannot change things, right? Now, if we wanted to convert from a list to a tuple, so for example, here we have our messages, which is a what? It's a list, right? So if we print type dot, or just type, you have a type function You could type in messages here. And what that does is print to the user what type that is. And we can see it's a list, right? Set up to be a list. If we want to convert that to a tuple, because we would never change this, then we would say tuple, and we would pass in the name of that list, which is message. Okay. And we would have something like messages equal tuple message. So now if we were to look at that type, print type messages. We could see, not messages, type messages. There we go. You can see now it's considered a tuple when we print it out. Again, the only difference is now I cannot manipulate messages. I cannot say messages dot append something cool. Right? I wanted to add another message up here. When I go to run this, I cannot append to a tuple. You could, but if it's something that would never change, then you would want it to be a tuple. Or if you didn't want the user to ever change that list, right? Obviously, you'd have to have the code built in for them to change it. But the reason you would do that would be, again, things like if you had API keys or a timer in your app or something like that that would never change, you would put it inside of a tuple so that you could reference it that way. And because they never change, tuples are really, really fast. So if you have a list of all these messages and you never intend for it to change, make it a tuple because the program will operate faster that way. Now, as small as our programs are, it's not going to affect it, but you get into a really big program with hundreds of entries in there, it would be much faster to use a tuple. Right? You can likewise use the opposite. If this was a tuple, like this, if I wanted to convert that over to a list, I would say list messages. Now I can take that tuple, I converted it to a list. Now I can start manipulating and do whatever I want with it. Maybe when I'm done, I convert it back to a tuple, and then it's back to a really fast environment. Okay. You can convert things like a string over to a list. So say I had something like my string equals Jason is awesome. Just go with it and spell it correctly. There we go. If I wanted to convert that to a list, I could say list my string, right? I could say my string equals list my string. And so now that we've converted it to a list, I can do things with it. So if I print this my string and I run this, we can see now it converted that string over to a list with each individual character as another item in that list. Now I could append to it, I could end it, I could do whatever I wanted, right? Or if I wanted to print one character out on every single line going down, I would say what? For I my string, great. Not print my string, but print I. Great. We can see it goes down that way. So what that did was it took one character out of here, printed this one. This became the character I, because that's what we said. Instead of I, you could say something like char, right? We have char. And what that will do is print the character. Same thing, right? It just gave more meaning instead of I, is all that did. Right? And we'll print each character going down. Say I wanted to have a little time delay in there and doing that, right? I could import time. And then for each one of these, I would print time dot sleep. And let's sleep for 1 second. You would see something like this as it goes down. All right. It's a little slow. Probably wouldn't want to go with 1 second. Let's do with 0.25. Something like that, right? There you go. That probably isn't as cool as maybe you have something else. So some of you guys are going to do text adventure games for your midterm. So what that would look like is say you have a paragraph of text that you want to spit out line by line, right? You could create that in here where you would say paragraph, just for the sake of it, paragraph, and then we would have a list. And the first line is something like, hello and welcome to my game. Right? And then the next line is something like, you will be exploring vast mountains and valleys. I don't know, I'm making this up as I go here. I really can't pick which one of those quotes I want to use. And you would just keep going on down the line, right? So I'm just going to fill some stuff in here for now. Okay. Now, what we could do is we could just roll through that paragraph. So for line in paragraph, print line, something like this. And we'd see it spit it out in a nice line here. If we added that time delay in, time dot sleep, and let's add a fraction of a second, in this case, quarter of a second, it'll look something like this, like you're reading it in. Maybe 0.25 is a little too fast. Let's do 5. Okay. And if any of you played old school text adventure games, this is kind of what it looks like when you go through, right? But say we wanted that to do more of a typewriter type effect where it was writing it all the way across as it went, right? So then what we need to do is we need to do that same for loop on the line that's being passed in, right? So we would say for line in paragraph, and then we would say for char in line. Then we print the char and we do a time dot sleep of say 0.25. And then after each line, we're going to sleep for 0.5 seconds. And what that will do is give you this effect. Is that kind of what we wanted?
No.
Okay. So what do we need to do? The problem is when we print that character, what's at the automatic implicit of a print? Anybody remember that? There's a new line character, right? Remember, we have this little effect called end equals, and then by default, it always has this new line character. Well, if we tell it there's no new line for that, right? That it's just empty. Now, it's going to start printing out each character as it goes across there. And in this case, because that typewriter is a little slow, let's use 0.1. We can see it's writing it out more towards us now. All right. It'll go all the way through that line. But notice the way we have it here, what's happening?
So
All right. It never has a new line character. So what we have to do is at the end of that line, we have to make sure that we print a new line before we sleep. So you'd have something like print. And now it's going to print out each paragraph in each text. Okay. So you can make some really cool programs just by tweaking and printing those out with a little bit of a time delay. It's putting together what you guys already learned, right? We just took a paragraph and have all of our text and our lines in there. And then you just loop through that. You take that one line, then you're going to take the char for that line and move its way on down. Pretty cool. All right. It doesn't matter. So you'll notice I start with a single on this side and I've done double on this side as I've typed here today. It doesn't matter which ones you use. The benefit of using the double quote is that if you have any contractions inside your sentence, it won't have any problems with it, right? So if I had it's all good, notice how it closes it even if I put one at the end. Now this text got off. So if I'm always in the habit of using doubles, then I don't have to escape that character. But yes, it'll accept both. My fingers just do what they do at this point. Okay. All right. References. So the way references work are, if we say spam is equal to 42, okay, and we say cheese is now equal to spam, right? So cheese is now what? 42, right? If I say spam is now 100, well, now spam is 100, but cheese remained 42, right? So we assign that value when we do this. Does everybody see how that works? So if you copy a variable, so to speak, here, just know that if you don't reference or change both those variables, the old one's going to stay the same. Everybody get how that works? Okay, when you do this with lists, so if I say spam equals this as a list, and I say cheese is equal to spam, and then I modify cheese one hello, notice that the output of spam and cheese is the exact same. It will change it. All right, so when you're dealing with lists and you try to copy them, so to speak, you are actually creating a reference of that list, not a copy. So if you change one thing in one, it's automatically going to change one thing in the other. Everybody get that? If it's just a number or a string, it won't affect it. But if it's a list, it will affect it. Okay. Let's see here. They talk about the ID function. You guys don't really need to use the ID function. What that does is just return back a Python unique identity so that you can reference this string howdy. This is just a reference number for it. Okay. For most of what you guys do, that will be irrelevant. There's no reason to really use that. Okay. Let's see. Passing references. We talked about this in our functions. So if we create a function called eggs and we want to pass in some character, then we call it some parameter, whatever we want. From there on out, inside of our function, we will use the phrase some parameter. So on the outside, if I have something like eggs and I pass in this spam list, right? When I pass spam into this function, it is no longer referenced as spam. It's being referenced as some parameter, meaning that I can pass whatever I want through there. Normally, you would call these two the same, but there may be a reason that you never call it the same. Maybe you pass in multiple different lists into that function. Therefore, you make something generic up here that makes sense from within your path, your function. All right. If you do want to copy lists, you use what's called the copy module. All right. So we import copy at the top. We have a list like this, spam. We say cheese equals copy.copy spam. That's going to create a whole different list for us, which means if we modify spam, we do not modify cheese anymore. Does everybody get that? So if you want to copy a list, you need to use the copy module and you use the copy function. So copy.copy. All right. If you have lists inside of lists, you need to use deep copy in order to copy those inner lists. So if you had a list that had lists inside of it, for example, I had another list inside of here that was numbers. I don't know why, but we're going to go with it. Like that you would need to use deep copy in order to copy this paragraph list. All right. So if we look at this, what do we got? Another short game. Conway's Life. Kind of looking through here just to make sure I didn't miss anything in summary. No. Okay. So those are all the topics. You guys should play with these different practice projects this week. All right. Code them to see if you can get the results out of that practice project. Everybody see how that works? All right. What's another cool thing with the list is you can kind of treat it like a grid like this is doing. So these are coordinates, right? So this would be your X coordinate, Y coordinate. And you could actually make it print out some little character grid like this. This one here where, let's see, you got the coin flip one, which is a really good one. This comma code, this used to actually be a homework assignment. So see if you can solve this. The idea is you have a list that looks like this. It wants you to write a function that takes a list value as an argument, okay? Returns a string with all the items separated by a comma and a space, and then inserts the word and at the end, so that the result would look like this. You have apples, bananas, tofu, and cats. However, the way you write your function needs to work with any list value that you pass to it. Anybody have any idea how they'd start that one? All right. You need to know this one because this is a good way to figure out whether or not you know what we've been doing, right? So let's take a look at this one. We got time here today. If I could shrink this so that we can see both. All right, let's dissect this one a little bit. It wants us to give us this list. So let's just copy and paste our list in here. Okay. Our result should print something to the screen that looks like this. Okay. It wants us to do that by, first thing it says is write a function. So how do you guys write a function? Do you remember? DEF, and then whatever we want to call it, right? So let's call it what? Tiger power. Why not? All right. We need to take in a list into this function. So we're going to call this my list inside of here. And once we get that list in, we need to be able to create this as an output. Does anybody have any idea how we could create this as an output? Well, what is this? If we look at it, what is that? It's a string, right? So we would want to start with maybe an empty string. Let's start with something like my string, because I am horrible on variable names today. And we have an empty variable list. How would we add the first thing in this list to this string? Better yet, how could we go through this string and just add that up to this my string? Does anybody know? We could use an append, but an append goes to a list, not to a string. So the first part of this is, how do we go through this list? When I say I want to go through a list, I have to put it in a, no, you're not far off. When we use the range, we use that in a for loop, right? Perfect. So in order to go through a list, if I ever say go through a list, you want to use a for loop right off the bat. Okay. So we say for item in my list, right? That is going to make item the first thing in this list. The second time it goes to bananas, tofu, and cats. Okay. So I have this string up here at the top. I need to add to that string. Does anybody remember how I could add to a string? There you have it. She's looking it up. We learned it today. String concatenation. You remember the shorthand for doing string concatenation?
Plus equal.
Even this case, it would be something like my string equals my string plus item, right? That's one way of doing it. What's the shorthand way of doing it?
Plus equal.
Plus equals. So plus equals item. So what that's going to do is take whatever comes from this list, it's going to add it to the string. All right. So if we call this function, how do we call that function? We're in the main script. How do you go back and say, call this function we defined up here? Yep, great call. So just tiger power, and then we need to pass this list into this function. How do we do that? We just type in spam. Okay, so what this does is it calls this tiger power function, and it's going to send this spam list into that function. Once it gets into this function, is now called my list. All right. Once it's inside this function, we now reference it as my list. It's no longer spam. So if we do this, and at the very end, we print my string, just so we can have an idea of what we've got so far. Let's see what we got. Okay. Well, it did kind of what we wanted it to do, right? It took the item out of that list. Let me see if I can get both of these on the screen here. Okay, so our for loop started with an empty string, and then it went through and added each one of these pieces in. Does everybody see how that worked? For a better idea, we could go like this. Let's print my string up here so that we can see it build. So the first time it runs through, we have apples. The second time it goes through this loop, it adds bananas to the end. Then it adds tofu, and then it adds cats. But what do we need in order to get the output to look like this down here? A space and a comma, right? So we need a comma and a space before it does the next one. So we would say item plus comma space, right? So let's try that. Now we have apples, we have bananas, tofu, and cats, right? So we finally got what we wanted out of there. So we know how to build it one by line. We're going to erase that my string out of there. Now, how do we get it to look like this one? We have to add an and in there, but we only add an and when it's the last thing in the list, right? So what is the last thing in a list? -1. Oh, great. So we could use our index to say, hey, if this is equal to -1, then we add an and to it, right? Otherwise, just run the code that we had. So we could have something like so what we would do here is where we're adding this line, we would do a check first to make sure that we're not at the last one on the list. So it'd be if item equals my list -1, aka we're at the last thing of the list. If it equals that, we would want to add what? My string plus equals what's that? And space and, right? And then we would say with a space after the and then we are going to add whatever that item is. Okay. In this case, we know that it's cats. If it is not that last one in the list, aka else, then we're going to do everything that we were doing before. And so now if we run this, how do we look? We got too many spaces, so we need to kill this space right before and. All right, let's run this again. Does this string match this string? And the answer is yes, if we actually put those quotes on there, right? There you go. So it's not a super complicated problem, right? We did this in probably 6 lines of code, but you just have to think through how you would add that in there. So we have this original list. Now, what was the check that we needed to do here? But your function should work with any list value that we pass to it. Okay. So what happens if we don't put apples in there? Maybe we have cats and we have donkeys and we have tigers and clowns. I don't know. There we go. We run this. At the very end, it always adds comma and, right? The reason that they're wanting you to do this in this fashion is because we are using Python to determine what the last one is. We don't want to hard code and say cats in this case. If it's cats, then do this. Well, that wouldn't work if we changed our list. So the way we wrote it, it automatically works no matter what. It's always going to check the last one in the list. If we didn't have -1 and we had to use an index number, what would we have to do? How could we figure out what the last one in the list is?
That.
Lin. Okay, so Lin of what? My list. Minus one, and we would need to make sure that this was in parentheses around here, right? Actually, you don't really need parentheses there. So you could do the length of the whole list minus one would give us the last one in the list. And it would function and work the exact same way. There you go. All right. Now, what happens if instead of spam, I have something like another list equals, and it's an empty list? And instead of passing spam into our function, we call another list. Or it's nothing, right? If we go back to the original problem, it says, be sure to test the case where an empty list is passed to your function. So we would want to print something like what? There you go. So how would we calculate it being an empty list?
If land of mine. 0.
Then what? There you go. And then we would do what? An else. And we put everything that we just did under here inside of that, right? So now the first thing we're going to do is check to see if the len of the list is 0. If it is, we print an empty list. And if it isn't an empty list, if we don't pass in another list, we pass in spam. We can see that it works just fine. All right. So don't be afraid of these practice projects. Just take little chunks and work all the way through it. Break it down into chunks. First thing it does, say write a function. Okay, well, we know we need to start off with writing a function that takes a list value as an argument. Okay, that means that we need to pass in some kind of list into this. Okay. It says returns a string with the items separated by a column. Well, did I return a string here? No, I didn't. I just printed the string, right? It wants us to return that string, not print it. So we need to return my string. And if I wanted to print it, I would have to do a print call down here in order to print those results. So that's one thing you'll want to watch is if it says return, that we just return it. Same thing works. The difference is this function will always return and not print. If you want to print it, you got to call it out here in the main part. Return just builds that strings up and sends it back to the main program. So when I break this down, if I run this function, Tiger Power Spam, then once I run it through this function and everything comes back, it returns essentially my string. And whatever that string is now inside the print function and it prints it. But you may not want that to necessarily print. That's the reason we don't do a print. Say this was calculating a bunch of age and we didn't necessarily want it to print. We could just tell it to return that back. Or we're doing some other manipulation down here. We don't care. This should just return a string. This will be important on homework assignment 3. When we get to that one, I will say, write a function that does this and returns a value, which means it should not print when I call that function. Only if I pass it into a print function. Okay, that's the reason I used to have this one as a practice one. So let's double check the rest of this. Write a function that takes a list and an argument. Got it. Returns a string with all the items separated by a comma and a space with an and inserted before the last item. Boom, string returns that. Okay. For this one, it gives us the output. So we know something that we can check our output, make sure we match it correctly. And our function should be able to work with any last list passed into it, which we checked here with donkeys and everything else, which means just don't hard code it. Does that get what this part means? If it can work with any list, it means doesn't matter what we pass in here, do not hard code this as a for loop. Last but not least, make sure that an empty case, if it's passed, we tell it it's an empty list. All right. You guys feeling comfortable now? Just keep practicing with it. That's the best way to do it. Come up with something goofy and build something similar to this. You're in charge of building the roster for a soccer team. Write a function that will create the roster of a soccer team and prints out the results. And it randomly picks who the starters are for the soccer team. Okay? What would that look like? Okay, so let's start over with that. All right. We have team, okay, as an empty list, oops, equals an empty list. We want to create a function that would allow us to input a bunch of team names. So that's our first function. So what would that look like? Def get names, something like that, right? Doesn't matter what we have. In this case, we're not going to pass anything into it. So we're just going to gather the names from the user. So what should we start with? You're not wrong. We would have a team, right? And that would be this part. Okay, and then we want to get stuff from the user. So what do we need to do first? We have to have some kind of an input, right? So we could say name equals input. If I could do this right here, we got that input prompt. Before that, we probably want some form of a print statement, right? Telling them what to do. So add player to team. Something like that. And when we're always doing inputs, we should probably have that inside of a what? Anytime we do an input, we should always put that inside of a what? So that we can check to make sure. Not closer. You're on the right path. A while, as you say, while. Okay, yeah, while loop, right? So we put that inside of a while true. That allows us to get that from the user. Then we can use an if statement to make sure it's right. If an if statement works correct, we break them out of the while loop. Okay, so we could say add player to the team. We could also say print, press enter to exit. What that's going to do is if we don't type anything in, then we can exit out of the program. So what's the first thing we should check? If they exit out, which means name is equal to what? Nothing, right? So if name is empty, then we need to exit out of this while loop, which is a break, right? Else, then we need to gather the input from the user, which we have. We could sanitize that. And in this case, all we're doing is what? We're just going to add it to a list. So we need to do what? Append, right? So team.append, and we're going to append that name up to the list. Once they are all done out of this loop, then we will go ahead and return team. All right, so this function is to get all the team members, and we're going to run them through this function to get it all through. When they have added the last team member, they press enter, it exits out of the while loop and returns it back to the user. So if we have a print down here that says, welcome to my team roster program. All right, print, enter 1 for adding players. You guys did something like this last time, right? Print, enter 2 to randomly pick, I don't know what, soccer. How many players you need? Like a lot. Let's go with 3 players. So let's randomly pick the captains, right? That's 2. All right, so we're going to randomly pick our captains. Okay. And we could print enter 0 to exit program. All right, what else might we want to do with this simple little program? You could go that far. Let's just print the whole roster. That makes sense? So enter 3 to print roster.
And that's where we would put the team instead of description.
Right, we would take the results of team then at that point and go all the way back. So what we want to have is you're going onto something there. So what we need to do is first we have our if statement, right? And at this point we need to gather it. So choice equals input greater than there. And we could put this obviously into a while loop. So while true, we get a choice. We can start with our tests. I don't know why this is giving me problems here. There we go. All right, so if choice, what do we have here? There you go. So if choice is less than 0 and greater than 4, is that what you said? 4. It wouldn't be greater than 4, it'd be greater than
Oh, yeah, sorry.
3, right?
Yeah, you're. No, it is.
If you wanted to do that, if choice is greater than, what you're trying to do is make sure they typed in a valid number, right?
Yeah.
Okay. Because we're having them type in a number, what value is coming in on this input? Is it a string or an integer? It's always a string, right? So instead of checking to make sure that they typed in a valid number, instead of us converting it over to a number, then checking to make sure it's a valid number, we could just check against the string. Saves us a lot of code. So instead of having to do these checks, we could simply start off with equals 1. Right? Because if it doesn't end up equaling one of these, then we just kick it out and say it's not a valid choice. You're on the right track. It's just by converting it to an integer, you have a whole lot of extra code to write at that point. So if choice is 1, what do we need to do? Run get names, right? So we will call get names and it will go do that. Now, the only problem is when we return this, it returns it back as something, right? It would be better if we had our team starts out as an empty list out here and we pass team into this function. So we could just say team. The idea being that if they wanted to add players later, we just simply add whatever teams that they return back to us and send it up, right? To use this team that we're adding modifying, instead of passing it in there, why don't we use the global team so that we modify this outside list? Everybody see why we're doing that? Okay, I know you guys are almost time to get out of here, and it's close to the weekend, so I'll be quick here. So get names equals team. That's going to call this local list of team, and therefore we would start adding it until they have an empty one that goes through. Okay. There. All right. Elif choice equals what? 2. We want to randomly select 2 players. So how could we do that? There you go. We import random at the top. Down here, we could just do it in this line. We don't need to create another function. So what would that be? Captain 1 equals what? Random dot choice. Pass in team. Perfect. Captain 2. Same thing.
We'll check on it to make sure it doesn't put the same person.
There you go. That's a great programming part. So what she said is we need to first check whether or not we didn't just pick the same person out of there, right? So there's a couple ways we could do that. We could say now if captain 2 equals captain 1. Just rerun it, right? And we could put this in a while true. And if this is an else, break. Right? Everybody see why we did that? Okay. Then we could print out to the user, print your captains. And then we could do something like plus captain 1 plus space plus captain 2. Okay, what's our last one here? Print our roster. So LF choice equals 3. Yep, thank you. Good catch. Okay, how would we print our roster in alphabetical order? Team dot sort. And then we could what? Do something like print team roster. Now give it some kind of title header, right? And then for player in team, print team or print roster player. Okay. And last but not least, LF choice equals 0. We want to end the program. Does anybody remember how to do that? Yep. Import sys. And then down here, we use sys exit to exit the program. And we should probably give them a bye-bye message. Okay, let's see what we got here. All right, we got a roster program. If I have 3, nobody's in our team roster, right? So we might want to have a check in there that would say if it's empty, just print nobody's in the team, right? We could enhance that later for the purposes of this. This will work great. So 1, we need to add a player. So we're going to put Caden in the team. We'll put in Sierra and Luke and Jesse. This is a way for me to test my names here today. And so Lee, right? Okay. All right. The Aiden. Ian. Yep. See, I got it. Alex, Gage, Oren. You were Luke.
Yeah.
Your name I missed. Brian, that's right. With an A in it.
Mike.
What was it?
Mike.
It is Mike. Okay.
Oh,
Abel. All right. We're going to leave you off for now on purpose. Hold on. All right. I'm hitting enter. It's not exiting our loop. Anybody know why? Well, up here, we just said press enter and we're checking to see if name input is equal to an empty string. In this case, we would just say none because actually the value of that input coming back is just none. Okay, so let's run this again real fast here before we get everything in. 1. I'm going to run through this real fast again. Caden, Sierra, Jesse. See, I'm going to get this all good here real quick. Now, Brian, Sophie, Aiden, Alex, Gage, Oren, Abel, Mike. We're going to purposely leave Luke off for a second. And it's still not working. All right. So we would have to fix this name input. And I don't know why it's not working because it should be working. I'm missing something rather obvious there. Anyway, if that worked, then we would go down and do that. If we needed to add Luke at the end of it, we could just rerun 1, right? And we could test and randomly pick. Let's check our captains real quick. Of course, we can't do that because it breaks out of here. So instead of this, let's do for I in range of 1, 2, 4. Team dot append. All right, real quick, I'll get this through here. Okay, so one, we're gonna add players. We have, once again, Caden, Sierra. It's only gonna add 4 this time here anyway, Jesse and Brian. And it still didn't exit. I didn't exit that. Oh, I'm in a wild tree. I need a break. So you do this enough, you get enough practice, you can go through there. 1. Is it not breaking out? I don't know, it's broke. We'll do better coding next time. I broke my own code. All right, we will see everybody. Why did that not work? It's gonna drive me insane. That's like the most easiest basic code. Team, append the name. Break out of that once it does it. Actually, it should have broke right off the bat. Because that's horrible coding. Okay, we'll come back to that in better choices. Okay. We shall see everybody. Oh, I see why. Because I'm actually at the main screen here. And we forgot to put an else in here saying that you typed the wrong thing. I am in the main menu. So if I now do a 3, I got my Cades. And if I do a 2, I broke it even worse. All right. We'll see you guys next week.